Does yours say find the distance and the midpoint between that and that? You can cross that out. That's actually from the old curriculum. I meant to nuke that and I forgot. Whoops. Slope. The slope, yep. Did I miss you guys? Okay. That's because I don't like you, Sam. Oops. Slope of a line is a number, and the number describes how steep it is. The bigger the number, the steeper it is. Really steep, really big slope. What do you think the slope of a line with no steepness would be? 0? And then we're going to talk about the difference between uphill and downhill. Can anybody think of a clever way that we could distinguish between uphill and downhill? Think Science 10 vectors, positive and negative. Okay? So we've kind of worked some of this. In fact, some of you have done some slope already in your Science 10 class, perhaps. I'm going to treat it or teach it from scratch. So slope is a measure of a line's steepness. Look at the 2 ramps below. Which one do you think has a greater slope, ramp A or ramp B? So visually, it's usually pretty obvious, unless, Tyler, the steepnesses are really, really, really close together. Usually you can eyeball it and it's pretty obvious. What we're going to talk about is how can we get beyond visually and start to do it mathematically so that I can say exactly how steep something is. Slope is defined as the rise, how much you go up by, divided by the run, how much you travel across. In fact, the phrase that we use is we say slope is rise over run. Rise over run. In fact, I had a teacher who used to spell it like this, with a Y instead of an I, to remind us that the Y part was what went on the top and the X part was what went on the bottom. I'm not going to do that, but I always point it out. I wrote down here, use a ruler to measure the rise and the run of the ramps above and see if your prediction was correct. We're not going to worry about that just yet either. We're going to try and get to graph paper, so you can omit that. Trust me, ramp B is steeper. And if you measured the rise and you divided by the run, you measured the rise and you divided by the run, you would find that your decimal answer for ramp B was much larger. I should say, Marcus, in science, usually we'll do the slope as a decimal. In other words, when we go rise divided by run in science, we actually want you to do it on your calculator, 1.63 or whatever. In math, we usually prefer the slope as a fraction, not as a decimal. So instead of 1.63, leave it as 9 over 7, or whatever the heck it happens to be. What happens when the ramp is going the other way? We said, how can we distinguish downhill? What did we say? Decreasing. Oh, and Brody, it's always going to be the same order as you read from left to right. That's how we'll define uphill or downhill. Okay, so start on the left side of the graph, move your eyes across. Anything that's like this is a positive slope. Anything that's like this is a negative slope. And thank you for figuring out you should turn the page. Example 1 says, find the slopes for the following. Okay, first of all, negative or positive? I heard both. Which one, that one? We would call that a negative slope. What's the rise? The vertical part. 8 over, what's the run? The horizontal part. And in lowest terms, we would say that's negative 2 over 1, but I'm not going to write the over 1. I'm just going to remember, Brianna, that it's there. Does anybody know what's the symbol that we use for slope? We can't use S. It's taken by something else. We use a lowercase m. Why m, Mr. Dewick? Because not all math was done by English-speaking people. It's from a French word for mountain, steepness, slope. Stairs climb 5 meters for 3 meters horizontally. The word climb, does that imply uphill or downhill? Yeah, if I wanted to say downhill, I think I would have said stairs descend or some word along those lines. So climb, uphill, positive. What's the rise here, Anthony? What do you think? 5 meters? You with me, Anthony? Yeah. Okay. What's the run? So other words for rise: vertically, climb, rise, go up by, ascend. Other words for run: stretch, horizontally. Those are the main ones. B, I guess I should have done that before C, but that's okay. Positive or negative? And it's going to be 3.4 divided by 12.5. Now, in math, what we would do is we would multiply the top and the bottom by 10 to get rid of the decimal. We would say that's 34 over 125 and then reduce and leave it as a fraction. In science, we would write this as a decimal. In fact, you know what, to be honest, really, Brody, if you have decimals in your fraction, we'll treat this as a decimal. What is 3.4 divided by 12.5? Anybody?
0.272.
What comes after the 2? Oh, it works out evenly? Like, yeah. Sorry, it terminates? Doesn't work out evenly, but it terminates? Okay. D. Positive or negative slope if you read D? Ah, drops. There's a word that implies going down, yes? What's the negative? What's the rise? What's the run? Careful, it's not 1. Ben, the rise is 100 what? Meters. I have meters on top. You know what I better have on the bottom? Meters. So what's 1 kilometer in meters? 1,000. I think this reduces to a slope of 1 over 10. Any of you work construction on roofs at all? Most of you haven't yet. Sometimes I've had a grade 11 or 12 has. So if you work on roofing, when you're putting roofs, they'll talk about a 312 pitch. They're giving you the rise over the run. 3 inches up, 12 inches over. Or they'll talk about a 112 pitch. That's a fairly flat roof, 1 inch up for 12 inches over. Or they'll talk about an 812 pitch. That's a very, very steep roof. Nobody likes to work on those. That's 8 inches up for 12 over. Pitch, another word for slope, but in construction. Oh, but in construction, Greg, because they measure in inches, they give everything out of 12, because there's 12 inches in a foot. Construction hasn't gone metric yet. Now, to do this on a grid, we need to figure out how to find the rise and the run using x1 and y1, x2 and y2. If they give me a picture, I will draw a slope triangle. Now, I have to be careful. Before you start counting the slope, glance at the graph just to make sure that they haven't put a scale on here that changes what each square is worth. Certainly in science, you may find that when you're graphing stuff, not every square is going up by 1. It may be going up by 10s, maybe going up by 20s. So you might have to do some math as you count the number of squares. Here, can you look at this example and everything in example 2? Is there a scale on any of these graphs at all? No. We will assume each square is 1. But we'll always check. To draw the slope triangle, what I really do, Simi, and you may reach the point where you don't need to do this anymore, but until you get good, I go, you know what, let's go thicker, Mr. Duke. This is really the slope triangle. Draw it as a dotted line. I'll do it as a solid so you guys can see it, but do it as a dotted line. That makes it way easier for you to figure out the rise and the run. First of all, positive or negative, and how do you know? Positive uphill. What's the rise? Well, because I drew this triangle, it makes it much easier. Why don't I zoom in? I get it all on there? Sure can. Now I can go, the rise is 1, 2, 3, 4, 5, 6, 7, 8. What's the run? 1, 2, 3, 4. Which reduces to what? Mr. Dueck? Yes, Ben. I didn't do it that way. Did you do it that way? Could also have done this. Could also said, hey, Mr. Dueck, all I need are any 2 points. I could have, if I'd wanted to, Mr. Dueck, picked that point and drawn my triangle like that. Why might that be smarter? What's the rise? 2. See it? What's the run? Oh, you can get in lowest terms right away. In fact, in science, we generally try and use the endpoints nice and far apart because that gives us better data. In math, we'll often just say, pick the best points, which may be the easiest points, which may be closer together. But here's our first little, I guess, conclusion. Amber, any 2 points on a line have the same slope. The 2 big ones gave us the same slope eventually in lowest terms. The 2 middle ones gave us the same slope eventually in lowest terms. In fact, if you wanted me to define the meaning of straight, any points, the set of points between 2 dots that all have the same slope, that's a straight line. There's a definition of what straight might mean. So try doing the rise and the run for A and for B. I'll do it up here. Let's see if we get the same thing. Maybe not, Mr. Duke. I could be wrong. Hang on, let me take that back. Tried to fool me. Did you get negative 4 over 9 and positive 2 over 5? I almost got suckered in on the first one. For a minute there, I thought that that was actually a point that it went exactly through. But then I noticed that over here there was gaps. I said, I better take 2 nice far apart points first and make sure it works. That's why in science you tend to take points that are nice far apart. Generally in math, since we're making up numbers, they just are nicer and work out nicer and go through more points. What was this slope of a horizontal line? What did we say? How steep was that? 0. What about a vertical line? What about a vertical line? Well, we would say this. What's the rise? 1, 2, 3, 4, 5, 6, 7. What's the run? It's a trick question.
0.
What is 8 divided by 0? Not 0.
95.
I like undefined because that's clear. but some textbooks will say no slope. The reason I don't like no slope is you're used to the word no meaning zero. If I have no chocolate bars, I have 0 chocolate bars. It's not what it's talking about here. When it says no slope, what it really means is the slope doesn't exist. It's undefined. Now, Marcus did a little thinking. Marcus didn't say undefined. Marcus, what did you say, oh clever one? Infinity. In Math 10, you're wrong. Okay? In calculus, once we start giving you the mathematical rules for dealing with infinity, you're right. In calculus, we'll define that as an infinite slope. But if we did that right now, we would then be saying that dividing by 0 was legal because we would have divided by 0 and gotten an answer. And I'm telling you, in the real regular number system, we can't divide by 0. In calculus, those of you that plan on taking it, you'll spend the first month and a half finding a way to to divide by 0 without technically dividing by 0. We could say it's called a limit. We take it to the limit. And by doing that, then you can say, yeah, it's infinity. But you have to do some fairly clever mental gymnastics first. So I can't say you're wrong. In 2 years, I may say you're right. But right now, still can't. What if I didn't give you a graph? What if instead, put your pencils down. What if instead I just gave you 2 points and no graph paper? What if I said, find the slope between 3, 5 and 7, 12? How could you find the slope? And Greg, I don't want to draw it because I'm lazy. I can, but maybe my graph paper doesn't go 12 high. Or, hey, what if they're bigger numbers, like in the 30s? I don't want to be counting that many. Can anybody see how you can find the rise and the run from 2 points? Yeah.
Maybe you could minus the initial point from the final point. For example, like 7 minus 3.
You can. We're going to go final minus initial then. If you're going to use science terms, we're going to call this x1, y1. First x, second first y. We're going to call this x2, y2. You don't need to write this down. We'll put this in our notes in a second. If I want to find the rise, how high did we end up? How high did we end up? So go find y2. 12. How high did we start at? That's an x value. Can't be a height. Well, see, by the way, the tricky part is getting the numbers mixed up. So I'm walking you through where this came from. How high did we start out at?
12.
No, how high did we end up at? 12. How high did we start out at? 5. I think if I counted the number of squares, Alex, there would be 7 of them. That's my rise. Over. How far right did we end up? 7. How far right did we start at? The slope of that is 7/4. You want to find the slope, Amy, without graph paper? Subtract the y's, subtract the x's. Oh, but go in the same order. If you subtract second y minus first y, you better subtract second x minus first x. It would have worked the other way around, by the way, if I had gone 5 take away 12 over 3 take away 7. If I had gone first minus second, because that's what you suggested. If I had gone initial minus final, I get -7 over -4. But what's a negative divided by a negative? I get 7/4, same answer. What I can't do is go final minus initial on the top, initial minus final on the bottom. That's a no-no. we're going to solidify this. So back to our notes. You can pick your pencils up again. If I want to find the rise, just subtract the two y terms. If I want to find the run, just subtract the two x terms. Put your pencils down for a second. Here's what we mean. If I give you a point A, which has, don't write this down, first x value, comma, first y, that's too much writing. An easier way for me to write first x value is going to be x value number 1. And an easier way for me to write first y value is going to be y value number 1. And if I have a second point, hey, if the first point is called A, what would be a clever thing to call the second point? Very good. And that has a second x value and a second y value. Then I can subtract the y's and subtract the x's. The slope, second y minus first y, all over second x minus first x. You do not need to memorize that, although most of you will because you're going to get tired of looking it up. I've showed you, Curtis, how you can kind of scrunch your brain and figure it out yourself. Kind of makes sense. Hey, how high are you? Bigger minus smaller. How high are you? Well, I can't say bigger minus smaller. Second minus first, second minus first. Or first minus second, first minus second. I go second minus first. And in fact, pick your pencils up. That gives us the slope formula right there. Slope is y2 minus y1 over x2 minus x1, or rise over run. Which one's right? Yes. No, I mean, which one's best? Yes. Oh, if you give me the graph semi, I'll use the rise over run, which is what most of you are doing in Science 10, or will be doing in Science 10. If I give you points, and I don't have any graph paper handy, I'll use the slope formula. Okay? So, find the slope of the following, it says. This is where I see mistakes. And Ashley, by far, the biggest mistake is kids put the wrong points in the wrong numbers. They put the wrong stuff into the formula. So here's what I'm going to suggest. You may have noticed that I like maximum bang for minimum buck in terms of showing work, Amber. Here's what I'm going to suggest. When they give you 2 points, like that, really quickly with your pencil, write x1, comma, y1, x2, comma, y2. And by the way, it's xy, comma, xy, not xx, comma, yy, because that doesn't make sense. Your x coordinate is always the first one. Your y coordinate is always the second one in the bracket. By doing that, which takes you what, Greg, less than a second? I've learned over the years that gets rid of about 90% of the sloppy mistakes. So that's, I'll do that. What's the slope formula? Well, from that box up above, it's y2 minus y1 over x2 minus x1. Who's in science? By the way, don't write this down. It's technically change in y over change in x, because change in anything is final minus initial. Another way to say final would be 2, and another way to say initial would be 1. What's y2? Minus? What's y1? 5. I think the top will work out to 6. Yeah. Over. What's x2? Minus? And also by doing this, can you clearly see the minus minus? Do you think that gets missed if you try and do it in your head? Yeah. I think the slope of this is going to be 6 over, or in lowest terms, sorry? Don't think 1 over 2. 3, divide by 2, 3/4, yes? If you were graphing this line, you would put a dot at the first point, 4 left, 5 up, -4 comma 5, and then from there go up 3 over 4, up 3 over 4, up 3 over 4, up 3 over 4, and you can keep graphing that line. In fact, that's going to give us a shortcut to graph any line. If we know one point and the slope, we plot that point and we just start counting the slope from there. Down if it's negative, up if it's positive, always over to the right. B. Mr. Duick says go x1, y1, x2, y2, 1, 1, 2, 2. Try that one on your own. I'll do it up here. Let's see if we can get the slope together. Is that right, Mr. Duick? Do you get 8 over -8? Yeah. Which reduces to positive divided by negative. If you're graphing this line, go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Try C. Did you get what I got? Get -5 over 0? Then I wrote down, hey! First of all, what is -5 over 0?
Undefined.
Ah. So what kind of a line is this if it's undefined? Huh?
Vertical.
Vertical. What if the 0 was on top instead? Horizontal. A slope of 0. Mr. Duick's dumb way to remember these. So it's a vertical line. Homework. Let's assume each of these is going up by 1. Now, it won't always, so don't just start counting squares. You may have one semi someday where the squares go up by 2s. Then it's going to be 2 times the number of squares. Or you may be going up by 10s. Your rise and your run won't always be going up by 1s. And I'll change this assignment next year using one from a couple of years ago. Anyways, number 1. Two. 3. So far I've assigned everything. 4 is good. And then take a look at number 5. Are those squares going up by 1? In other words, if you're finding the slope of this first section right here, I think the run is 1 square, but how big is 1 square when you look at the scale? 1,000. The run's going to be 1,000, not 1. And how big is 1 square vertically? I'll let you do the math and think about it. So number 5, find the slope of each little section there. Oh, and I think 2 of your answers will be positive, 2 of your answers will be negative. 2 uphill, 2 downhill. Six is good, so you're going to find the slope of AB, BC, and CB and BC. Find the slope of all 3 lines that connect those 3 points without graphing them. It's a triangle. Oh, and I guess I can ask you to go backwards. I can give you the slope and say, can you figure out the missing point? I haven't done one like number 7. See if you can figure it out. Otherwise, I'll talk about it next class. And let me just... Yeah, that works. Yeah, I signed everything. Is that what you said? Oh, I thought somebody said, yeah, it's just everything.